Hi, I'm Kinkas and I'm a synth DIY guy. Welcome to the build and demo video for the Moritz Klein and ericasynths.edu system sequencer. This is the fourth installment in the complete video series I'm making about this amazing educational project. Building these kits not only gives you a sweet analog modular synth to play, but also the knowledge behind what the electronics are doing. Make sure you read the in-depth manual thoroughly. This is a simple analog sequencer with selectable 3, 4, or 5 steps, individual gate switches, clock I/O, voltage range selectable between 2.5 or 5 volts, and more. You can make unquantized melodic sequences with it, or use it in audio rate to create interesting wave shapes, among other things. The kit comes with everything you need to build it, including the panel, the PCB, as well as all of the hardware and electronic components needed. I like to start by organizing all of the parts in my work area, to make everything easy to find. Next, I plug in all of the diodes in their respective places, making sure they are oriented correctly. Then I proceed to solder them from above. Once they are firmly soldered in place, I turn the board around to trim the excess leads and check my work from behind. I then proceeded to plug in the IC sockets, making sure to align the byte on each socket with the corresponding marking on the silk screen. I then carefully turn the board around and place it on my mat. Solder just one pin for each socket while pushing the board down, ensuring the sockets are secure and aligned. I then proceed to solder the remaining terminals. Next, I install all of the small bypass capacitors. These can also be soldered on from the top quite easily, and they're not polarized. Just make sure to plug the 1 nanofarad one where it goes. The other 5 are all 100 nanofarad caps. Now turn it around to touch up and trim the leads. Next up are the resistors. I like to use my multimeter to check the value for each resistor strip before plugging them into their respective spots. I don't really trust my eyes and the color coding. Most of the resistors on this build go on standing up TP style. Make sure to line up the body of each resistor with the circle drawn on the silk screen. Then solder the exposed legs to keep them in place before turning the board around to finish soldering the other leads and trimming off the excess. Let's move on to the transistors. They're not all the same type. Make sure to plug the BC548 where it goes. All the others are 2N3904s. Just line them up with the silkscreen drawings and carefully solder them on. It's easy to create a short here since the leads are so close together. If you make a short, use desoldering braid or a pump to clean up the excess. Trim the leads and move on. Now plug in and solder the big white film cap. This one is also unpolarized. Oh, it looks like I left out 2 of the transistors. Time to plug them in. Now I'll use the snake charmer technique to solder on the first pin on the power header. Once I'm sure it's on nice and straight, I can solder on the remaining pins. Moving on, install the trim pots. Now we can install the electrolytic caps. These are polarized. Make sure you install them in the correct orientation. Solder and trim. Now's a good time for a thorough visual inspection. Make sure there are no shorts or cold joints and touch up as needed. Let's go ahead and plug in the panel components, starting with the potentiometers. Snap them on nice and straight. Now plug in the 5 LEDs, mindful of their orientation. These are polarized. But don't solder anything yet. Now place the jacks and the switches. Then carefully slip the panel on over the components. Tighten the nuts to keep it all snug. Then push the LEDs through the respective holes. Check to make sure the pots are turning freely and are not crooked. Then start soldering all of the panel components. Trim off the excess leads. Nearly done. Snap the ICs into their sockets, mindful of their orientation. And that's it. Finish tightening the nuts, check the power header for shorts, and plug it in to test and calibrate. Alright, so let's have a look at how to calibrate this module. So the procedure is very simple. First you turn all of the potentiometers fully clockwise. So now, if you have your range switch here on 5 volts, you should be getting 5 volts out of the CV output. So let's get a multimeter here. I'm going to put it on volts measurement, and we'll grab the sleeve with the ground here and the tip with the red probe, the measuring probe. Turn off the rack before pulling the module out, because it could short on the side here or something like that. And now, as you can see, there are 2 trim pots here. This one is the one for 5 volts, and this one is the one for 2.5 volts. So we're going to do these one at a time. We can turn the rack back on now. And as you can see, it says 4.754, right? Or something like that. So let's just make sure that all of the step pots are all the way up. Now I'm going to grab the trim pot and I'm going to turn it as I look at the multimeter until I can get as close as possible to 5 volts. Now, right now I have it all the way clockwise and it says 4.97. That's close enough. That's just like a couple of millivolts less than 5, which is certainly acceptable. All right, so we've done that. Now let's change the range switch here from 5 volts to 2.5 volts. And as you can see, it says 2.3 there. Now I'm going to turn the other trim pot, the one on the edge of the board over here, and we're going to turn that one until we see 2.5. There we go. 2.498. Yeah, that's good enough. All right. So this module has been calibrated. That was nice and easy. Turn it off before we plug it back into the rack. And now I can screw it on and we'll move on to demonstrating the module. All right, so I've already connected the saw wave from the VCO to the filter, to the VCF, the output of the filter to the VCA input over here. Now the sequencer itself has quite a few inputs and outputs over here, and we want the one that says CV out. We want that for now. We want that to control the 1 volt per octave input of the VCO. Okay. Now the one that says gate out, we want that to control an envelope generator. Now I should use both envelope generators because I want to trigger both envelopes, the one for the VCA and the one for the filter. So I'm using this little splitter here and I'm connecting to both gate inputs right there. All right, so let's turn the rack on these are the gate switches. So we have a step counter here. You can have 3-step, 4-step, or 5-step sequence. And we have the rate over here, which is how fast these are going. And as I turn on the gates, now they start triggering over here. And we still need to connect these envelopes to their respective destinations. So one of them is the filter, and this one, oh well, we want the out, not the inverted out. And this one's the VCA. Right. I had my VCO frequency too high. We can turn these down now. And we can have it be a 5-note sequence here. But it doesn't need to trigger every time, because we can determine which steps actually trigger the envelopes. Right? Now, this is the VCA. We'll let this one have a sustain. Right? And the one that goes to the filter will have no sustain, just a decay here. Let's make this a little slower. Here we go. These are all 5 steps. Cool. Let's give the VCA a little bit more decay for release. Open up the filter a little more resonance. There we go. Alright, so now I can just play around with the various voltages here. And again, if I put it on 2.5, you have maybe more useful range on the pots here, right? Now you're limited to 2.5 octaves variation. I think I'd prefer to have it be the 5 octave. Or 5 volts, 1 volt per octave, right? There we go. Now we can have these rests by turning off the gates. Not every simple DIY sequencer has this functionality with turning on the gates. So this is super cool. Cool. If you want a more traditional sequence, you can have the 4 steps here. Now notice there's a clock input over here, right? And a clock output. So I can synchronize the sample and hold, for example, right? Now I can use the sequencer as the main clock. We'll take the clock output of the sequencer and send it to clock in of the sample and hold noise there. Now, as you can see, turning this knob doesn't change the speed of the LED there anymore. Now, I can take the sample and hold output here and send it to another CV input of the VCF. Very cool. So now we have a random variation of the filter. Very cool. Make it more subtle. Make it more subtle. Envelopes. the 5 steps, I see this as a nod to Don Buchla. Don Buchla's Music EZO had a 5-step sequence. And knowing Buchla, it was probably a combination of some kind of component, limitation or feature, as well as a stick-it-to-the-man attitude of, no, we're not going to have an even number of steps in our sequencer because we want to make experimental stuff. We want to be different. So 5 steps is definitely different. Cool. Very nice. Now another thing you can do, of course, is use the sequencer for something else other than the VCO frequency, right? So let's pull this out of the VCO here. And now we'll use the sample and hold for the VCO. So we get this random sequence, right? And now we can use the sequencer for something else. So we'll take the CV out of the sequencer here. And we can stick it in to the filter. And now I can have a programmable filter cutoff sequence, right? Works very well for some very nice rhythmic stuff. Right? Goes about that fast. Here's just 3 steps. Here's 4. And here's 5. Now, what else can I do with this? There are definitely interesting things that you can do once you start running this sequencer in audio rate. You can use it as sort of a wave shaper, right? So a sequencer, let's undo this whole patch here, and we'll take the CV out of the sequencer, plug that to the VCA directly for now. Manually here. Alright, so I've plugged the SAW output of the VCO to the sequencer. Ah, check that out, huh? So we're running the sequencer in audio rate now. Super fast. Now we can... Already changing from 3 to 4 to 5 gives you different notes. And even kind of tunes. Right? Now, changing the steps, the step values, that's where you design your wave form. So right now, with all of them at 0, the voltage is just staying right at 0, so you're getting nothing. But as I turn even one of them, now I'm starting to hear that pulse, that short little pulse, right? Which means that within every 5 segments, only one is high, so that's a short pulse. Now, as I turn more of these, you start getting quite different sounds, right? You can really fine-tune your timbre that way. Very cool. And now I can control my oscillator with another sequencer. I have the step 8 here. There we go. Now we got a little sequence going there. As you can hear, we're getting these chiptune kind of tones now. You can really change them, see? changing the step count changes the sound and the central pitch. This is a cool sound right here. Now we can stick that into the filter before the VCA. Very cool. You can use one of the envelopes in loop mode to be a LFO for the filter here. Very cool. I can change the timbre here in real time. Now the gate output can also be interesting. See? If I turn all of my gates down, this is similar, but instead of controlling a continuous voltage as you do with the CV output, on the gate output you can just toggle a step on or off, and that's also going to affect the sound. Right? So with only one step on, you get this short little burst. If you have 3 on, you get closer to like a square wave. If you alternate them, so let's put this in 4 here, right? If I do 2 on, 2 off, you get this note. Now if I alternate them, you get an octave higher, right? Which makes perfect sense. But I prefer the CV out here. I prefer to have this continuous control over the amplitude of each step. So yeah, even though this Moritz Klein ErikaSynths.edu system is very simple and basic, it still affords you a lot of sound shaping possibilities. Here we got the ring modulator effect with the looping envelope. Or just let it be triggered by the external sequencer that I'm using. Very cool. So that's it for the sequencer. I hope you like it. Hope you like the video. And keep following the channel so you can see as we continue to build and play around with all of the ErikaSynths Moritz Klein ES.edu kits. Alright, see you soon and stay noisy.